Hello, welcome back to Mr. Kendrick's online math class. This is the second part of lesson 3.5, multi-step equations. You can turn to the next blank page in your math notebook and put this lesson title at the top. And remember, when we are solving equations, we are working to isolate the variable. We are undoing the operations that are on the same side of the equation as the variable. In this video lesson, we're going to be looking at solving equations by combining like terms as well as using the distributive property to isolate the variable. The first thing I would like you to write down in your notes is the steps that we take to solve an equation by combining like terms. So when we have an equation with like terms on one side of the equal sign, we're first going to combine those like terms, and then we're going to follow the same steps that we follow when solving a two-step equation. We're going to undo addition or subtraction, and then we're going to undo multiplication or division. Okay, so go ahead and make sure you write these down in your notebooks. You can pause here if you need, and push play when you're ready to move on. Alright, let's look at some examples with combining like terms. So this first example, the equation says 3x minus 8x plus 10 equals 25. So we have the like terms of 3x and minus 8x. So our first step is going to be to combine those first. So 3x minus 8x would be negative 5x. So now we have negative 5x plus 10 equals 25. And now we got rid of the like terms, and now we can undo the addition and then undo the multiplication. So next I'm going to subtract 10, and if I do it to one side, I've got to do it to the other. And positive 10 minus 10 will equal 0, so those will cancel out, and I'll be left with negative 5x on this side of the equation. And 25 minus 10 will be 15. Now I have negative 5x equals 15, so I need to divide by negative 5 to undo this multiplication, and we must do it to both sides. This will leave 1x over here, and then 15 divided by negative 5 will be negative 3. So x is equal to negative 3. As you're following along, make sure that you are writing these examples down in your notes. The second example here, we have 7a minus 10a plus 6 equals 15. So we're going to combine the like terms of 7a and minus 10a, and that will leave us, so 7 minus 10 will be negative 3a. So now we have negative 3a plus 6 equals 15. And now we are in a two-step equation, so we can undo addition and then undo multiplication. So our first thing is going to be to subtract 6 from both sides. 6 minus 6 is 0, so that will cancel out. We'll be left with negative 3a. And on this side we have 15 minus 6, which will be 9. We have negative 3a equals 9. So this is multiplication here, so we're going to undo that by dividing. And we got to do it to both sides. Negative 3 divided by negative 3 will just be 1, so we'll be left with 1a equals 9 divided by negative 3 will be negative 3. So a is equal to negative 3. And to check our answer, instead of going all the way back up to the top here to enter it into for both of these variables, once we combine those like terms, we can just use this equation here to check our answer. So we'll have negative 3 times a, which is negative 3, plus 6 equals 15. Negative 3 times negative 3 will be a positive 9, plus 6 will equal 15. So our solution is correct. Alright, I got one more example here for combining like terms. This one we have negative 5y plus 3y minus 2y plus 3 equals 9. So we got lots of y's here on that left side of the equation that we are going to combine. So first we can say negative 5 plus 3 will be negative 2y minus 2y plus 3 equals 9. Now negative 2y minus 2y, that will be negative 4y plus 3 equals 9. Okay, now we've combined our like terms. Now we can start undoing the operations connected to the variable. So that will be first starting by subtracting 3 to get rid of this plus 3. If we do it to one side, we got to do it to the other. 3 minus 3 is 0, so that cancels, and we're left with negative 4y equals 9 minus 3 is 6. And now we have multiplication here, so we are going to divide by negative 4 and divide by negative 4. So I'm going to step over here to do that. We got 6 divided by negative 4. So our answer is going to be negative because we have one negative in our problem here. And 4 goes into 6 one time. We get 4. Subtract here, we get 2. Now we need a 0. And 4 goes into 20 5 times. 4 times 5 is 20. So we get y is equal to negative 1.5. Then we can check our answer over here. We get negative 4 times negative 1.5 plus 3 equals 9. So we have a negative times a negative here, so our answer is going to be positive. And 1 times 4 is 4. And 1/2 of 4 is 2, so that would be plus 2, which would be 6. So 6 plus 3 equals 9. So our solution is correct. Y is equal to negative 1.5. Alright, so back to here, we want to make sure that we combine like terms first, and then we'll just do undo addition and subtraction, and then multiplication and division. Okay, now we're going to go ahead and look at equations with distributing. Okay, so if we have a multiplication problem where we need to distribute, we got to distribute first, and then work addition and subtraction and multiplication and division. Okay, make sure you get this written down in your notes and push play when you're ready to move on. Alright, a couple examples here. We got 3 times x minus 5 equals 24. So the reason why we need to distribute this 3 is because we have an unknown inside the parentheses, so we can't do the math inside the parentheses with that variable inside. So we need to distribute the 3 to both these terms inside, and we will end up with 3x minus 15 equals 24. Okay, and once we distribute, now we are into a two-step equation situation, and now we can work to undo our equation. So we have negative 15 that we are going to undo by adding 15, and if we do it to one side, we must do it to the other. Negative 15 plus 15 will equal 0, so we get 3x equals 24 plus 15 will be 39. And now our variable is being multiplied by 3, so we're going to undo that by dividing by 3. And we're going to do it to both sides. We'll leave x over here. And then 39 divided by 3. 3 divided by 3 is 1. And 9 divided by 3 is 3. So we get 13. X is equal to 13. Now let's check that real quick. And we can plug it in. We get 3 times 13 minus 5 equals 24. And 13 minus 5 is 8. And 3 times 8 equals 24. So our solution is correct. X is equal to 13. Make sure you have this example written down in your notes, and then we'll move on to the next one. Alright, second example over here, we have negative 2 times m plus 1 equals negative 10. So to start, we need to distribute this negative 2 to the m and to the 1, and we'll get negative 2m minus 2 equals negative 10. And now we are ready to start undoing the operations connected to the variable, and we'll start by adding 2 to both sides. Negative 2 plus 2 is 0, so we get negative 2m equals negative 10 plus 2 will be negative 8. Whoops. Negative 2m equals negative 8. So now we need to divide by negative 2. And that will cancel. We'll be left with m equals negative 8 divided by negative 2 will be a positive 4 because we have a negative divided by a negative. So m is equal to 4. And if we plug that back in, we get negative 2 times 4 plus 1 equals negative 10. And we get, doing the work inside the parentheses, we get negative 2 times 5, 4 plus 1 is 5, equals negative 10. Negative 2 times 5 is negative 10. So our answer is correct. M is equal to 4. Again, make sure you write this example down, and then we'll move on when you're ready. Alright, now we will finish up with a word problem here. We're going to write an equation, and then we're going to solve it. So, it says you have $43 to spend at the fair. It costs $25 to enter the fair, and $1.50 per ride. How many rides can you go on? Okay, so there's some important information that we need to pull out. We have $43, so that's as much money as we can spend. It's going to cost us $25 to get in and $1.50 per ride. Okay, so for our equation, we're going to start by, we got to spend $25 to enter the fair, so $25, and then it's going to be plus $1.50 per ride. Okay, so $1.50 per ride. So our variable is going to be the per ride. So we can use X for the number of rides that we're going to go on, and it equals, it cannot go over $43. Okay, so it's $25 to get in, and then it's going to cost us $1.50 for the number of rides that we go on, and we have $43 total. So we want to figure out how many rides can we go on. Okay, so in order to solve this equation, the first thing we're going to have to do is we're trying to isolate the variable, so we're going to get rid of this 25. Okay, so 25 minus 25 on both sides. And then we'll be left with $1.50 times the number of rides. And 43 minus 25 will leave us with 13 minus 5 is 8. So we still have $18 to spend on rides. Okay, so now our variable is being multiplied by $1.50, so we're going to divide by 1.50, and we got to do it to both sides. And now we'll have X equals 18 divided by 1.5. Okay, so I'm going to set that up over here. We get 18 divided by 1.5, Okay, remember when we're dividing by a decimal, we always want to divide by a whole number. So I'm going to move this decimal over to make it 15, and there's an imaginary decimal here that I'm going to move over here. So now we have 180 divided by 15. Our decimal will be right there. Okay, and then doing our division, 15 goes into 18 one time, and that would be 15. 18 minus 15 is 3. Bring down that 0, and 15 goes into 32 times. That would be 30. So x is equal to 12. Okay, so that means that we will be able to go on 12 different rides. Now, in preparation of going to the fair, I want to check to make sure that I can really go on 12 rides. So I'm going to plug this back in and make sure that I'm correct. So we get 25 plus 1.5 times 12 equals 43. Okay, so checking, we'll do this multiplication first. 1.5 times 12. So 1 times 12 is 12, and 0.5 times 12 is 6, and 6 plus 12 is 18. So we get 18 plus 25 equals 43. And we get 25 plus 10 is 35, and 35 plus 8 is 43. So our answer is correct. We'll be able to go on 12 rides at the fair.